Dear all, welcome to the playlist of High Voltage Engineering. In this session, I'll be discussing about testing of cables. First of all, let us understand what do we mean by cable. So cable comprises of two segments. The first segment is known as insulation part, you can observe here. The second segment is known as core part. The main purpose of insulation is such a way that current should pass through only the core part. So it prevents short circuit as well. So that's a peculiarity of insulation. So there are different varieties of cable. For example, PVC, that means polyvinyl chloride, VIR, vulcanized Indian rubber, then cross-linked polyethylene cable, XLPE cable. So many more varieties are available. If I talk about PVC cable, polyvinyl chloride, that is a material which you are going to provide as an insulation material. Now let us talk about how to test the cable. Now let's understand the various testing of cables. The first and foremost thing, the mechanical tests such as bending test, then dripping test, drainage test, fire resistance and corrosion test. The second type of mechanical test is known as thermal duty test. And the third one, that is belong to electrical test, that is known as dielectric power factor test. And the fourth and fifth test, that is power frequency withstand capacity and impulse withstand voltage test. Those tests are known as high voltage test or HV test. And sixth one is partial discharge test. And seventh one is life expectancy test or life test. You can call life test also. So these are the different varieties of testing which are applicable for cable and its insulation. So mechanical test, that is very simple. We need to check the rigidity of the given test piece. So normally these are the common procedures which are comes under mechanical test. So we are in the first test we are mainly looking at whether the cable is strong or it is good enough to withstand for a very long time. The second test is belong to temperature rise. So make sure that the temperature rise should not be happen more than 1 degree Celsius per hour. So that's a criteria or that's a protocol regarding thermal duty test. These tests are comes under mechanical test. And I'll be discussing the remaining part of the test. First and foremost thing, let me move on. Dielectric power factor test. So dielectric power factor test can be done with the help of shearing switch. So before conducting the dielectric power factor test, we require a test sample. Test sample has to be prepared. So let us understand more on test samples. In order to prepare over voltage withstand test, sample have to be prepared very much carefully. So that's the first and foremost thing which you are supposed to do. Sample has to be made ready. Otherwise excessive leakage or flashover will be taken place over that particular object. The normal length of the cable samples varies in between 50 cm to 10 meter. So that's the standard size of the test sample. The test sample has to be ready for all the type of electrical test. The terminations are usually made shielding of the end conductor with a stress shield. At the terminals of the test piece, you have to be careful. You have to provide suitable shielding. Okay, these are the first and foremost thing before conducting the testing. Before moving on to the testing, test sample has to be made ready. Okay, now let me move on to the dielectric power factor test. You can conduct this test with the help of shearing switch. Okay, that's the main segment which is required for conducting the test. HV shearing switch. I already discussed about HV shearing switch. Similarly, you can able to calculate the loss factor or loss tangent with the help of shearing switch. I mean tan delta. It is also known as loss tangent or dissipation factor or dielectric loss. So similarly, in this test, dissipation factor or you can call tan delta is measured at the following values: 0.5, 1, 1.66 and twice of the rated voltage of the cable. That we are going to check. Each cases you will be noting down the value of tan delta. How much dielectric loss will be taken place, that you are going to measure for every cases. Then shearing switch has to be given to a protection shield against over voltage. That is required. Otherwise breakdown will be occurred in the cable. So those precaution has to be made ready. Similarly, one of the main advantages of shearing bridge is such a way that balance equation is totally independent of frequency. So we can minimize errors in measurement. So that's a peculiarity of dielectric power factor test. Now let us discuss about high voltage test on cable. There are two varieties of HV tests which are applicable on the cable. Number one, power frequency withstand voltage test, and number two, impulse voltage withstand test. Let us discuss the procedure for HV test. Here, test sample has to be made anyway. Cables are tested for withstand the voltage using power frequency AC, then direct current and impulse voltage. So these three procedure has to be done. At the time of manufacture, entire cable is tested under HV for checking the continuity of the cable. That is required. At the time of manufacturing, this test has to be done. So let us discuss the procedure. There are three procedures mainly. According to the first procedure, the cable is tested under high voltage AC of 2.5 of rated voltage for 10 minutes. Make sure that no damage should be occurred. So that's the first procedure. Okay. Now I would like to discuss about the second procedure. So after the test, whenever you are applying high voltage and you are applying 2.5 rated value of that particular voltage, and you will be waiting for another 10 minutes and making sure that no damage is occurred. Once the first test is completed, let us move on to the second step. So once the test is successful for the first step, that means cable is tested under high voltage DC. You need to generate high voltage DC by using any of the method like Cockcraft Walton type DC generator set or high voltage rectifier. Any method can be used. So DC voltage test consists of by applying 1.8 times of rated voltage for half an hour. You will be applying 1.8 times of rated voltage for 30 minutes or half an hour. Make sure that test will be successful. Okay, your test object will be surveyed for this condition. Moving on to third procedure. Once the test piece is overcome the second condition, we can go for the third condition. In the third condition, we require impulse generator. The impulse voltage of prescribed magnitude as per the specification is applied, and the cable has to withstand 5 applications without any damage. Okay, you need to generate impulse waveform. Okay, at least you need to generate 5 times of application for that particular test object. Make sure that your test will be successful. For the 3 cases, your test object should be surveyed. Then only we can say that HV test is applicable on that cable and you can apply for any application. Okay, these are the 3 procedures which are comes under HV test. So make sure that for 3 steps, nothing should be happened over that particular material. Okay. Now I would like to discuss about partial discharge test. In case of partial discharge test, you can go for discharge detection method. Apart from discharge detection method, there are many more varieties are available. There are many methods are applicable. Let us have a brief discussion on that. So partial discharge will be depending on partial discharge will be mainly depending on internal discharge, electric stress and voltage stress. So you can do the partial discharge test in different manner. So procedure is number 1, discharge detection method. Number 2, location of discharge. Number 3, scanning methods. These are the major steps regarding partial discharge. Okay, partial discharge has to be tested based on the following methods. You need to understand the following procedure: how to conduct discharge detection method, and how do you predict the location discharge, and finally how to conduct scanning methods. Let us have a brief discussion. First and foremost thing, let me move on to partial discharge test such as discharge detection method. So first and foremost thing, we require a cable and its insulation. We need to represent the cable and its insulation by using an RLC circuit. As you can see, this is one of the LRC. Here also you can observe LRC. So by using this LRC circuit or RLC circuit, you can represent cable and its insulation. Okay. So this is required for the analysis. Now let us understand how to conduct discharge detection method. So what is discharge detection method and how you are going to check the partial discharge? As you can observe in the diagram, we have a cable. Okay, we are going to consider a cable. Suppose fault is occurred over here. The thing is, the cable is connected. This is your cable that is connected to a discharge detector through a coupling capacitor. Coupling capacitor that helps to connect different stages. Okay. Now what you are supposed to do is you need to pass the traveling wave from one end of the cable to other end of the cable continuously. Okay. So traveling wave has to be passed from one end of the cable to another end of the cable continuously. Okay, so traveling wave is mainly used for the testing purpose. Suppose the fault is occurred over here. When you are traveling when you are passing the traveling wave from one end of the cable to another end of the cable, if the fault is occurred here, it will be directly reflected at it will be merely visible at discharge detector. Okay, that wave shape is getting deferred. So you can understand the cavity. You can understand that some cavities occurred here. Therefore, it will be leading to partial discharge. So this method is known as discharge detection method. In order to improve the transient response of the given circuit, so you can connect more number of cable and it will be improved the transient response. Okay, so serious error can be detected. That's another peculiarity. So error will be depending on shape of the detector. So the clarity of the detector, the accuracy of the detector is also very much important over here. So testing of long cable, you can go for this method. Okay, in order to improve the transient response, so we are making the structure in this. Here also you can observe, you will be passing a traveling wave from one end to another end. So coupling capacitor that will be connected to different stages. So you can able to observe the changes in the discharge detection or that particular device. DD means discharge detector. Okay, in that detector, the shape will be available, and by using that particular shape, we can analyze. Okay, that's the thing regarding discharge detection. This is a modified circuit. Okay, by using this, we can improve the transient response. Now I would like to discuss about the second method, that is known as location discharge. Okay, by using the discharge detection, we can able to find out any cavity or any voids which is present inside your cable. Let us discuss about location discharge. So here also we require traveling wave. It is mainly used for the testing purpose. If any void is present, you can see the drop in traveling wave. By finding out the drop in traveling wave, we'll come to know that there will be a void which is present inside the cable. So that is one of the very important tests related to partial discharge. Measure the duration of wave or pulse and the distance at which the discharge takes place from the cable and can be calculated. That's also possible by using this method. The shape of the wave or pulse that depends on the nature of discharge. Suppose any shape has been varied, we'll come to know that some partial discharge is taken place inside that particular cable. That's a peculiarity. Okay, it is mainly making sure that any void is present or not inside the cable. If any void is present, definitely that leads to partial discharge. We can observe the attenuation of the traveling wave. So I'll be showing some graph or some diagrams. With the help of that diagram, we will come to know that the partial discharge is taken place or not. Here you can see a sudden drop. So there will be a sudden drop of the waveforms. So that is representing the point discharge. Sudden drop you can observe. These are the waveform which you can observe from the discharge detector. And this is representing the void which is presenting inside the cable. This can also be observed from the detector. Okay, so time is also observed over there. We can easily analysis. We can do the analysis very easily, and we can make sure that location discharge method is also one of the popular method for measuring partial discharge. You are checking the drop. If you talk about the location discharge, so we can consider these circuits for the measurement of location discharge. These are the various circuits. So RC network which will be helpful for measuring the location discharge, so that you can measure the partial discharge. So consider the verification of location discharge. If you found a sudden drop, in the traveling wave, and of course we can say that there will be a partial discharge. So this is the way how you can measure partial discharge with the help of location discharge method. Okay. So you can observe there is a attenuation. There is a continuous attenuation that will be happening on the traveling wave. So that we will conclude that there will be a partial discharge. Now let us discuss about scanning method. How to conduct the scanning method. So scan the overall cable for checking the voids or imperfection in the manufacture. That's the peculiarity of scanning method. So let us discuss the procedure. So bare core cable is passed to the high electric field and discharge location is there. That's the first procedure. Moving on to second procedure, the core of the material is passed through a tube of insulation material which is filled with salt water or distilled water. 4 electrodes will be placed over the arrangement, just like a ring-like structure, and they should have electrical contact with water. And we can check where exactly the occurrence of discharge. No observation should be made. Now I would like to demonstrate this scanning method. Okay, so let me have an observation whatever I understood, I'll be representing with the help of a schematic diagram. Now let us discuss about scanning method. You need to consider a beaker. One simple beaker you have to consider. So inside the beaker you will be filling the distilled water. Okay, like salt water. Let us discuss about salt water. So we are going to fill with the salt water. Okay. Likewise, salt water will be filling inside your particular beaker. Okay. This is representing salt water or distilled water. Let me call this one as sodium chloride. Okay. Now, I'll be taking the sample of cables. So you need to consider sample of cables. So this is your sample of cable. Okay. Test piece. I have already told that you need to maintain the test piece first. Okay. This is your test piece. That means test piece. Let me write. This is your test piece. Test sample or test piece. Let me write a test sample. Anything is fine. Okay. So I have considered a test sample. Later what you can do is, you need to arrange 4 electrodes. So let me arrange 4 electrodes. This is electrode number 1. Now I would like to arrange 3 more electrodes. Electrode number 2. Similarly, electrode number 3 here. And electrode number 4. 4 electrode I have arranged. Thereafter I need to apply high voltage. I will be applying high voltage. I am going to apply high voltage over here. I will be applying the high voltage. Between those electrodes, I will be applying high voltage. So you have to wait for half an hour. Wait for half an hour. Keep on observing. If you found any discharge which is happening inside the setup, obviously something is happening inside your particular test piece. That means the test piece which you have selected for this application, that is having some partial discharge. There will be some kind of partial discharge that will be taken place in this particular section. So this is actually not fine, and you need to replace this particular test piece. Okay, so this is the way how you can able to conduct the scanning method. By performing scanning method, the discharge can locate at the length of cable. That is another peculiarity. This method is one of the most popular method to identify any partial discharge is taken place inside the cable test sample. The defective part can be easily isolated by using this method. That is another advantage. Then it can increase the perfection of insulation production. Surely it can be done. And it can isolate defective insulation from the factory site. And we can, it is one of the major thing which can be used for quality control department, quality assurance and quality control department in any type of industry. Now let me discuss about a life test. How to conduct life test. It can also be called as life expectancy test. How to conduct this? So it is mainly used for reliability studies. Able to determine the expected life of insulation. I mean, how long insulation can be survived, how long we can use the insulation. A cable are performed under normal stress and the maximum stress. That can be done. Consider a test piece. It has to be done for normal condition and the stressful condition. It is established that the relation between the maximum electrical stress EM and the life of the cable insulation in hours, that means in terms of time, approximately follows one relationship. There is one relationship between EM and T. Okay, that we have to measure. There is one relation, there is one equation, empirical formula. Based on that, we can able to predict how long the insulation material can be survived. So as you can see, this is one of the empirical formula, one of the equation that Em is given by K into T to the power minus 1 by N, where Em is the maximum stress. Okay, K is known as constant, which depends on the field conditions and material. It varies from PVC to VAR material. It may be varying from VAR to cross-linked polyethylene. Clear? N is known as life index, which depend on the material. Okay, that is also depending on the material to material. The duration for conducting the test is 1 hour to 1000 hours. So from this we can able to predict how long the particular insulation can be survived. From this you can able to calculate N, and you can verify that how long the particular test piece can be survived. Okay, that is very clear. I have referred the following textbook. In this session I have discussed about the various insulation testing. We have found these are the major 7 tests which can be applicable for testing of cable and its insulation. The first 2 tests that is mainly belong to mechanical test. Okay. Similarly, 4 and 5 test that has a major role, that is known as HV test. So we are conducting the test based on high voltage AC, then high voltage DC and impulse voltage. Okay. So we'll be confirming that your test piece will be survived. Similarly, test number 3, that is actually dielectric power factor test, that can be done with the help of Shearing bridge, and partial discharge, which comprises of 3 segments. So by using the 3 procedure like the scanning method, discharge detection method, likewise many procedures are there in partial discharge. So I could explain the scanning method with the help of a pictorial manner or graphical manner that I already explained. Finally, you can able to compute how long your insulation material can be survived with the help of life expectancy test, or simply we can call life test. So these are the various tests which are applicable for insulation testing. Thank you very much for watching this video. If you found this channel useful, please don't forget to subscribe. Thanks a lot.